Welcome to the introductory notes for section 2.3. We're going to continue thinking about the derivative and get some derivative rules down in this section so that we can find some derivatives a little bit more efficiently than using the limit definition. So the first question says, what is f prime of x for f of x is equal to 3? I think we've seen an example like this, but this is just the limit as h approaches 0 of f of x plus h minus f of x divided by h, but that limit is the limit as h approaches 0. F of anything in this case is 3, so both of those terms in the numerator are 3, and this limit then just is 0. So in general, if we take the derivative of any constant, that derivative is just equal to 0. So there's our first derivative rule right here. The derivative of any constant is equal to 0. Okay, we've seen some facts using the limit definition of the derivative. We saw that the derivative of x to the 1/2 power, or the square root of x, is 1/2 x to the negative 1/2. The derivative of x squared is 2 times x. And I'll tell you one more fact. The derivative of x cubed is 3 times x squared. We can see a pattern going here, and that pattern would allow us to write down what's called the power rule. In general, if we take the derivative of x to the n, so what happens in each time, the thing playing the role of n, 1/2, 2, and 3, ends up being the thing playing the role of the coefficient of the derivative. And so that means it's n times x, and how does the exponent change? In each case, the exponent is 1 less than it was initially. So n times x to the n minus 1. So there's our second derivative rule. It's the power rule. And it would allow us to take a derivative like the derivative of x to the 7/4 without having to use the limit definition. So this derivative, the power rule says, take the thing that's in the exponent, make it the coefficient. So that's 7/4 x, and then whatever that exponent was, raise it to 1 less power. So to the 7/4 minus 1 power, or 7/4 x to the 3/4. Okay. Good. How would this change if I had asked for the derivative with respect to x of 3x to the 7/4? Well, it really wouldn't change at all, except that the 3 would just come along for the ride. This would be 3 times 7/4 x to the 3/4, or 21/4 x to the 3/4. Excuse me, we take the derivative the same exact way, and that constant comes along in that calculation. Okay, so we want to now explore, that allows us to take derivatives pretty quickly of polynomials, but we want to think about now products, sums, differences, and quotients of polynomials. So let's use two functions to explore this, the two that were on the first page there, x squared and the square root of x. So if f of x is x squared, its derivative is 2x. G's derivative is 1/2 x to the negative 1/2. F prime plus g prime is just the sum of those two derivatives. And so with sums and differences, things work out pretty nicely. The derivative with respect to x of f of x plus or minus g of x is just the derivative of f plus or minus, whichever is there, the derivative of g. So sums and differences, nice. So now if we have a polynomial function, we can just take the derivative of each of those terms individually to find the derivative of that polynomial function. Products and quotients, though, let's explore what happens when we think about products and quotients. Okay, so I filled in part of these tables for you. Let's look at products. So here's f, there's g, f prime and g prime already filled in. And let's fill in the rest. What is f times g? Well, f times g is x squared times x to the 1/2. So we would add the exponents there, and we would get x to the 5/2 power. Okay, what is f prime times g prime? It is 2x times 1, 2 times 1/2 is 1. So I get x to the 1 plus negative 1/2. So I get x to the 1/2 power when I multiply f prime and g prime. And now, what if I take the derivative of this thing? I want to know the derivative of the product of f and g, well, that 5/2 comes down. And it's x to 1 less power. 1 less power, 1 less than 5/2 is 3/2. Okay, so the key here, though, is that these two things are not equal. Right, so we can see from this one example that the derivative with respect to x of f of x times g of x is not equal to f prime of x times g prime of x. So it works nice. We can take derivatives across addition and subtraction, but not multiplication. And let's look at something similar for quotients. Okay, there's f and g. There's not a lot of room in these blanks, so I might write outside of them. So if we want to fill in here f divided by g, x squared divided by x to the negative, x to the 1/2, sorry, would be x to the 3/2 power. And then there's f prime and g prime, and if I divide those, 2x divided by 1/2 x to the negative 1/2, so that would be 2x, let's write it down, divided by 1/2 x to the negative 1/2. Well, that's really an x to the positive 1/2 when it's in the denominator. So this looks like 4x to the 3/2. And what is the derivative of f divided by g? So I want to take the derivative of this. That's 3/2 comes down, and we get x to the 1 less power, which would be the 1/2 power. And again, the key here, not as nicely organized, is that these two things are not the same. They are not equal. Or written again, the derivative with respect to x of f of, sorry about that, of f divided by g does not equal f prime of x divided by g prime of x. Okay, normally I would motivate one of these for you, the rules that are going to come once we see that we can't just take derivatives this way with products and quotients. I'm going to state them for you here, and then if you want to stick around and watch the end of this, we'll prove one of them if you're interested. So here they are. If f and g are differentiable, then the product rule, the derivative of f times g is f times g prime plus g times f prime. So that one's going to be key. And the quotient rule, the derivative of f divided by g is g times f prime minus f times g prime all over g squared. So those two rules are going to be needed. So let's put them in the practice here, and then I'll prove the product rule for you. Imagine the quotient rule proof is in the textbook if you're interested. So find h prime of x here. So let's see, we want to think, let's break this down. We'll be more efficient as we gain practice with these things, but let's be really clear here. So h of x, if I use the notation above, that's f times g for f of x being equal to x to the 8th and g of x being equal to 6 minus x squared. Oops. Okay, so we know the derivative is based on the derivatives of f and g, and so we can write those down. So f prime of x is 8x to the 7th from the power rule, and g prime of x, well, the derivative of a constant we learned is 0. So we get 0, the 2 comes down, we get minus 2x to the first power. So that is just negative 2x. Okay, so then h prime will follow the product rule above. It says write down f. So f is x to the 8th. Multiply that by g prime. G prime is negative 2x. Add to that g of x, which is 6 minus x squared. And multiply that by f prime is the last step, which is 8x to the 7th. Okay, I guess we could simplify this thing a little bit if we wanted to. This looks like minus 2x to the 9th. 6 times 8 is 48 plus 48 x to the 7th minus 8x to the 9th. So this is 48x to the 7th. Gosh, again, sorry about that. 48x to the 7th minus 10x to the 9th. You don't have to do the arithmetic to simplify that. If you were asked to find the slope of the tangent line to h, you would just evaluate that at whatever value you've been asked to find the slope of the tangent line at. Okay, let's do something similar here for s. Here, this function s of x looks like a quotient. So it looks like f of x divided by g of x, where again, f of x is played by x to the 8th, and g of x is played by 6 minus x squared. And so as we saw above, f prime is 8x to the 7th, and g prime is negative 2x. Okay, so s prime, let's follow the quotient rule. It says, if we look up at the quotient rule here, it says write down g of x. So g of x is 6 minus x squared. Multiply that by f prime, which is 8x to the 7th. Subtract f of x, which is x to the 8th, multiplied by g prime, which is negative 2x, all divided by g of x squared. So g of x is 6 minus x squared quantity squared. We may be able to simplify that a little bit, but no need to do the algebra at this point. Okay, so there's an application of both the product rule and the quotient rule. They really come down to recognizing what two functions you're dealing with the product or quotient of, and being able to follow the rules as stated. So if you're interested in the proof of the product rule, it's coming. If you aren't, feel free to stop the video here and head into the section 2.3 activity and see if you can put these two rules into practice some more. Okay, here's a proof of the product rule using the limit definition of the derivative. So the derivative of f times g would be the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x times g of x all over h. So that right here is just direct application of our previous limit definition of the derivative. And then we make one nifty move in here, and that's really it. We take, if we look at what's happening right here, all we've done is we've inserted into the numerator negative f of x plus h times g of x plus f of x times h times g of x. And another name for that is just 0. That highlighted piece is 0, so we haven't changed the value of this quantity at all. And from here, we just do some algebra and separating of limits. So we can factor an f of x plus h out of two of the terms. We get f of x plus h times g of x plus h minus g of x. And we can factor g of x out of the other two terms. Then we can break this into two limits. And let me show you where we're going to do that. We're going to break this into two limits at this plus sign. So that plus sign is this plus sign. And we can bring the f of x plus h out in front of that limit. That's the same product. Do the same thing with the g of x. Then we're going to break again into two limits, and this time we're going to do it at this product right here and right here. So that gives us the limit as h approaches 0 of f of x plus h times the limit as h approaches 0 of g of x plus h minus g of x all over h. Something similar there to finish out the rest of that equality. And now we can take those limits. As h approaches 0, f of x plus h is going to approach f of x. So this first limit is this limit right here. Then this limit, the limit as h approaches 0 of g of x plus h minus g of x over h, that's just the limit definition of the derivative. So that's that limit right there. Then the next limit, the limit as h approaches 0 of g of x, well, there's no h's changing, so that in fact is just g of x. And the final limit, the limit as h approaches 0 of f of x plus h minus f of x divided by h, that's just the limit definition of the derivative. So that is f prime. Okay, there's the proof of the product rule. Feel free to go put the product rule and quotient rule into practice in the section 2.3 activity.